Okay. So when we did the last lesson, I wrote, do you remember that huge expression I wrote? Okay, filled with X's and Y's and numbers, some exponents and things like that. And I told you what X and Y were, and I said, okay, figure out the value of this. Okay, and we said, well, we want to try and make it simpler first before we plug it in. So this is the first way we can make things simpler, called collecting like terms. Okay, so like terms. Yes. Have the same variables and exponents if there are exponents. But the coefficients, if you remember what that word means, can be different. You remember what a coefficient is. If I said 7a, what's the coefficient? 7. If I said negative 5k, what's the coefficient? Right? Negative 5. Okay. So let's just look at these, see whether they're like or not like. 5x and 7x. Yes. Like. 5 and 7. Yes. Yes. They don't have variables and exponents, which means that they're like. If one of them had a variable with it, then they would not be like. 4y to the third and negative 9y to the third. Do they have the same variables and exponents? Yes. Negative 5, z to the fifth, and 3z to the second. No. Different exponents. Could be more than one variable. AB, 6AB, and negative 10AB. Yes. Yes, they all have ABs. Negative 6m and negative 7n. No, different variables. So once we've established whether they're like or not, or whether if they are like, we can combine them by adding them together or subtracting them. Okay? That is called simplify. So we can simplify like terms by adding or subtracting how would you simplify 3a and 7a? 10a, just add the 3 and 7. So this would be the same as 3 plus 7 followed by an a, which is 10a. You don't need to write this. I'm just showing you how we get it. Negative 8x's plus 5x's. Negative 3x, because you do negative 8 plus 5. And then follow that with an x, and you get negative 3x. Negative jk minus 3jk. We talked about this before. What number goes here? Just write it.
1.
So isn't it the same as negative 1 subtract 3? And then followed by jk. What is negative 1 subtract 3? Negative 4. So it'd be negative 4jk. 5x squared and 2x squared. 7x squared. I'm just going to write the answer. Okay, pretty straightforward. Eight a to the fourth plus 5a to the fifth. Yeah, can't do it, can you? Because they're not like terms. Can't simplify. Now we're starting to get some longer expressions like that one that I wrote. Well, how do we deal with these? Just highlight the ones that are like terms and combine them. Julia? Yeah. Because we can do 6x, remember always look at the sign in front, minus 2x, and positive 3y plus 10y. Remember, every time you see a variable sitting there and it doesn't have a number in front, there is actually a number in front, we just don't write it. So I'm just going to remind myself that's 1. So what would this one be? 6a minus 4. The 7a minus 1a is 6a. Negative 9 plus 5 is negative. There's a longer one. I recognize the like terms. So I see an xz in another, or sorry, not like. I see, come on. Yeah, when I combine those, I get 1xz or just xz. Okay? If you write the 1, that's fine. I can combine the yz's. Yeah. Positive or negative? I've got 2 and minus 5.
Negative.
Negative 3yz. And then I've got negative 8, which can't be joined with anything else, but I'm still going to write it as part of my answer. Okay. And finally, so again, you may just want to underline them or put them in boxes. So I'm just going to remind myself those two are like, which make 3x to the third plus 2x to the third, 5x to the third. Then I've got a negative x squared and a positive 9 squared plus, what was it? Yeah, x squared or 1x squared. The x's, I've got a minus 3x and a minus 6x. Negative 9x. And the constants, which means no variables, I've got a plus 3 and a plus 1. Plus 4. Okay. You try the next one. Anybody want to take a shot?
Squared
2n squared
plus 2n
plus 2n
minus 4.
minus 4. So you can get. Remember, always look at the signs in front. Okay, so here's an example where we can actually save a lot of time. We're given an expression, polynomial. We're told that a is -2. If I plug -2 into all of these, that's going to take a long time to calculate. What I want to do is I want to see if I can make it simpler first before I plug it in. So like, let's say, you're calculating the profit of something, of a business, and you come up with this whole formula. But I want to make it easier to work with. So simplify first. And what would I get? Well, if I combine the a squareds, what do I get?
39. Oh, wait.
I got 14 and I got -25. Yeah, 14 minus 25.
-11.
11? -11. Good. 38 and 15a
45.
plus 45a. -11 plus 3. -11 plus 3. -8. Now, it's much easier to work with. I mean, it's still going to require some calculation, but better than before. So now we actually evaluate by plugging in every time we see an a, -2, in parentheses. Don't forget the parentheses. It will help you. It is your friend. All right, so now we've got to start calculating. What do I do first here?
The square root of it, like square.
Yeah, so what is -2 squared?
4.
Positive 4. Okay, and -11 times positive 4, -44. Plus
45.
times -2. What's 45 times -2? -9. And that's going to just change to a minus. So you didn't even have to write the plus minus. You could have just written minus. And then a -8. So just remind yourself that this is a minus. So now they're all negatives that we're combining. So it's like 44 and 90 and 8 with a negative in front, which would give us
142.
yeah. So the ultimate goal is to evaluate expressions, but we always want to try and simplify them first when we can, okay? Because it makes them easier to deal with when we are asked to evaluate. So private. Here we're given a rectangle. We're not told the sides, we're just told the sides The length is 5 times some number subtract 2. And the width is 2 times some number. So you can't find the perimeter unless I tell you what x is. Okay? But if we want to find the perimeter and we're told in B that x is 4, I want to make it easier to deal with before I plug 4 in. How do you find the perimeter of a rectangle? Add up all the sides. So this side, 5x minus 2, plus this side, 2x, plus this side, which is, so we got to add another 5x minus 2, plus this side. So I've got a long expression, but if I look at it, I can simplify it. I've got a bunch of x's I can combine. I've got a 5x, positive 2x, positive 5x, positive 2x. What does that mean? 14x. And then I've got a minus 2 and another minus 2. Minus 4. Well, this is a lot easier to deal with than this. So, now that I'm asked to evaluate it, and I'm told that x is 4, I plug 4 in and calculate. And 14 times 4 is 56, and then we have to subtract 4 to get a final answer of 52. And remember, we're doing a problem-solving question, and there are units. So don't forget the units. 52 centimeters. Okay. Okay.